Okay, so if you remembered in our Grasshopper tabs, there was a tab called Sets, right? And we had come in here occasionally during our first 2 weeks to, use some of the tools that are available. Specifically, I think we use things like the list length, right? Or maybe the list item. We might have also touched on a little bit the culling tool, right? When we were trying to remove items from a list. Yeah. And I think we talked briefly about trees as well, specifically the flatten and the graft, right? So what you'll find is that most of the tools that are geared towards organizing data or managing data, they're all available to you in your sets tab, right? So specifically, you have things that are about reorganizing lists in your lists tab. You have data matching stuff down here as well. And in the sequence tab, you have things that are more related to generating data or modifying data, right? Rather than kind of extracting from it or reorganizing. And from there, the main one that we'll be looking at is the tree tab. And this is more or less to extract specific data or modify the structure of the data that we have, right? So the first topic that's really fundamental to understand in terms of working in Grasshopper parametric modeling is that you know when we have components and they have multiple inputs, right? Typically, what we're going to be looking for is for the data that gets inputted into it to be matching somehow, right? I think last somewhere, I forgot where, in the first 2 weeks while we were doing those exercises, we came across a situation where maybe we had a component, and I'm just going to pick something random here, right? Let's say a pipe, and it had a curve as an input, radius input, and caps input, right? And you know, the number of items coming into the curve may be different from the number of items coming into the radius, right? And that will affect how that data gets matched, right? I think by default, you may say, okay, well, I'm going to have a curve here. So I'm just going to draw a curve and import it in quickly for this example. And I'm using a container for this, set one curve. So now we have this curve inputted. And there we have it, right? Now our radius here, obviously we can use like a slider. And actually more than just do 10. Right, so we have a slider that can change the size of that radius, right? But we've always kind of been looking at this as a one curve coming in and one value for the radius coming in, right? But what if instead of one curve, we had three curves? So I'm going to set multiple curves, right? Oops, sorry, the original curve was no longer there. So, all right, so now there are three curves in this list. And if we use our panel, we can see we have reference line, reference line, reference line, right? So three items, right? All coming into curve here. And if you remember, we talked about, the fancy line under displays, fancy wires under the display tab. So when we had just one object, right, it was a solid line like this. And now that we have multiple objects in a single list, we have, these kind of double lines, right, to indicate that the structure of the data that's being sent is now a different level. And if we had several kind of lists within the same thing, then what we would have would be this kind of dotted line, right? So, we saw that a little bit earlier, and we'll talk about that a little bit again, probably when we get to trees, but just note that, those things are changing here, right? And so the result that we got was what? We got this operation, the pipe operation, happening 3 times, 1, 2, and 3, right? Now, during those 3 times, the 3 times that this operation executed, right, there were 5 items here. Sorry, there was a value of 5 set for this radius, right? And so it just repeated that value 3 times, right? Every time one input came in here, it took this data, right? But what if instead of having one data input, we had 2, right? And now you can see, well, it matched one object with this 5, right? And then the remaining objects, it assigned this value 10, right? Because 10 was the second value that we connected to this radius, right? So what that means is, like, if you connect multiple items to the same input, you're essentially creating a list, right? That it's going to cycle through, right? But when this list runs out of values, it will just keep repeating this last value, right? 10, right? And that's why we have 2 lines with the value 10, because we had 3 objects here and only 2 objects here on this list below, right? So that's what we call a dating matching issue, right? And it may be an issue, it may not be an issue, depending on, what you're trying to achieve, right? But I think in general, in most cases, this is not, an ideal situation. And what you would really like is that, well, if I have 3 values up here, I would like 3 values down here, right? To match up with them, right? So 5 goes to 0, and then 1 goes to 1, and then 2 goes to a new value down here, for instance, right? So that's what really we're talking about when we're talking about data, this idea of data matching, right? So let's do a quick example of how this works just using text. And then we'll look at it again in a little bit more detail with a graphical example, right? So in order to do this, we're going to use from our parameters, we're going to use a text container, right? And this text container is just going to hold our list of text items, right? And we're going to use our panel and manually enter values for this, right? So I'm going to say red. Then I'm going to push this down a little bit. Copy, paste. Copy, paste. And then I'm going to change those values to, something else. Red, orange, yellow, green. Right? So that's one set of input data possibilities, right? And then we'll create another set to match up to it, right? And so this set will be, let's say, dog. Let's make this cat, right? So we know that if I connect this to the container here, just like we did before, that it's going to put them all together into a single list, right? And the order in which I connect them is the order in which that list will be generated, right? So if I look at that list now, you can see that it says, okay, you have created one list with 4 values, the first being red, second is orange, third yellow, and fourth green, right? If I connected them in a different order, right, the order here would change as well. So you need to be, when you're connecting these components together, you should realize that in many cases, actually, the order in which you connect it will make a difference. Okay, but so anyways, now we have two containers, one container that created a list of colors and the other one created a list of animals, right? Now, if we go into our sets and we come to the bottom three components, right? Like I said at the beginning when we were introducing this, these are our data matching tools, right? So we have something called a longest list, we have something called a shortest list, and we have something called a holistic, right? So holistic is also known as cross-referencing, right? Which means every option is matched together, right? The shortest list is essentially what happens when you prioritize the two lists, the shorter of the two lists coming in, right? And the longest list is what happens when you prioritize the longest list that's being fed into it, right? So you can see that all these have two inputs, right? List A and list B, list A, B, right? So we have here our A and B, and we'll just connect them all up first and see what the difference is in the results that we get are actually. Okay, so right now all we've done is we've created those lists and we've told it to match using 3 different strategies, right? And now we want to be able to see what's happening, right? So in order to do that, we're going to use the fragment. What? I forgot. It was here. Concatenate. Here we go. Okay. So all concatenate does is put fragments of text together, right? You can see here we also have this one called characters, right? And that breaks them apart. But for this example, we're going to use concatenate, right? And we're just going to feed list A into list and list B into this concatenate using the longest list strategy, right? And then let's look at using our param viewer, the results that we get, right? So actually, let me add a space. Okay. So the result that we get using the longest list method, right, is you can see that red gets matched up with dog. So it gets red dog, right? Orange gets matched up with cat. So we get orange cat, right? Yellow gets matched up with cat again, right? Because we're prioritizing the longer list of the two, right? This one has 4 values and this has 2 values, right? So we get yellow cat, right? And then green matched up with cat as well to get green cat, right? So you can see that the behavior of the longest list component prioritizes this list that has 4 items, right? And continues to generate new data so long as there are values here, right? In order to do that, because our second list has fewer items than our first list, it had to continually repeat, right, the last value on that second list, right, which is cat. So we have cat appearing 3 times, right, in that result. If we do the same thing, right, but we now use the shortest list strategy, you can see that we only get 2 results in the end, right? We have a red getting matched up to dog, as well as orange getting matched up to cat. But yellow and green are completely omitted, right, from our final solution, right? And the reason for that, again, is because it's this component, right, tells us or tells the tool that we wanted to prioritize the shorter of those two lists, lists A and B, right? So it's putting priority on this list that has 2 items rather than the list up here that has 4 items, right? And so once the list with 2 items runs out of values, right, it stops the procedure altogether, right? And so you don't get any additional values in your output. Now let's look at what happens when we do the same thing using a cross-reference strategy, right? So with a cross-reference strategy, you can see that we're getting more values than the first 2, right? And the reason for that is that when you use the cross-reference strategy, it's essentially matching up every possibility available, right? So it goes first to the first list, says red gets matched to dog, orange gets matched to dog, yellow gets matched to dog, green gets matched to dog, right? Then once that's done, it says, well, nothing's been matched to cat yet, right? So I need to do it again, right? Red to cat, orange to cat, yellow to cat, green to cat, right? So we get 8 values total, right? So you have every color of dog and every color of cat getting matched up together, right? So before we look at a graphic example of this, one thing to understand and to be clear about is that the longest list behavior is the default behavior in Grasshopper, right? So if I didn't even use this component, the longest list behavior, I connected it directly from here to here, you can see that nothing changed, right? Both of them are the same. And that's what I mean by being the default behavior, right? You don't need to do anything actually to tell it to do this. This is what it will do automatically. Now, the question then is, well, why do I need this component then if it already does it automatically? And there are instances where you will want to be specific because, for instance, maybe, part of the data you want it to be treated in this way, and then another part of the data you want it to be treated in a different way, right? And you want to have both options available to you, right? Those occasions are rare, right? But, it doesn't hurt to have this component so that it allows you a way to deal with that, right? So that's pretty much the only reason that we have that component available separately instead of just accepting the kind of default value. Okay, so I think, well, try that on your own, but I don't think we're gonna, stop now and for you guys to practice. I think we should go ahead with the graphical example first, right? And maybe then I'll stop and let you guys have a chance to kind of review everything, right? All right, so let's set up a situation where some of this would make a difference, right? So, typically when we're working in Grasshopper, right, we're working with graphical tools and not purely with data like this, right? So let's set up just a simple example of what it could be, right? And so in this example, we're just going to make a couple lines, right? And we're going to use some subdivision to, maybe create points to connect. And then we'll use that as a example for how to, what the graphic implications could be for a situation like this, right? Okay, so we want to set up a couple lines basically, right? So I'm going to go to my curves. I'm going to go to my SDL line, right? And the way that the SDL line works is pretty straightforward. It takes a starting point and a direction as well as a length to define, right? So the starting point by default is not defined, right? So we need to give it a starting point. And I think in this case, what we can use is our plane XY, right? And because there's a default direction and length, right? You can see that there's this little line that gets generated automatically that's pointing up. Now we can change this direction if we wanted to, and but if not, we could also leave it on its own. Again, to change it, you would, maybe come in and define a vector. And that vector could, of course, be, in three-dimensional space, or it could be just in the coordinate directions X, Y, and Z, right? I'll leave that up to you guys. The length, let's have a slider to control that. So in this case, we can control the length. And that's our first line, basically, right? So on the next one, because I want to be able to generate a set of points on a second line to match up to, right? I'm just going to copy that whole thing. And then I'm going to use a move under transform tab to change the location that it gets generated at, right? And I guess I can just move it in the, what direction is that? The X. Oops. You know what? I'm going to move this all after here instead. So now I have two lines, right, that are offset from one another by a certain amount, which I can also define. Now, I think the good thing about defining it like this is that, I can come in here and I can change this, the length of the lines individually, right? As we understood about moving, right? It's the same as copying. So I could have just done this once and then copied it over, but then the two lines would have always been forced to be the same length, basically. So I just prefer be able to play around with the definition a little bit more later on. So I'm going to go ahead and set it up as two separate lines from the very beginning. Right now, right now, they're just two lines in space. And actually, these two lines are only serving the purpose as a guide, right? What I would like to do is I would like to divide those lines into parts. And so I can do that if I go to my curve and my utility, right? So again, I'm hmm, oh, sorry, there's another one called division in this instance. So under curve and division, I'm going to use the divide curve component. And what this is going to do is it's going to allow me to divide that curve into segments, right? And however, the output is points here in this case, right? So it's more, even though it's called divide, it's more like putting a certain number of points onto that line, right? Now I can define the number of points, right, by changing the count. So now they both have 10 points on them, right? And if I wanted to establish some relationship now between these two, what I could do is use a line primitive, right? And draw a line between those points, right? So you can see what's happening here is that I basically have generated two lists, right? So one list with 10 values, and a second list with also 10 values. So, right, if we, output 10 values to here, and then we output 10 values to here, and then we say draw a line, right, between those points, then what's happening is it's taking 0 as a start point and then 0 down here as an end point, right? So it draws, one line from here to here, right? And then it takes 1, right, as a start point, and then 1 down here as an end point, right? Whatever that value is. And it draws a line from there to there. And it repeats that process 10 times. Actually 11 times, right? Because we start at 0 and we end at 10. And then we get, what looks basically like a ladder, right? What happens then if you imagine I change this second list, right? So that it only has, say, 7 values. You can see that because of the longest list matching strategy, right? We have value 0 matching to 0, 1 to 1, 2 to 2, 3 to 3, 4 to 4, 5 to 5, 6 to 6, and then 7, right? Matching to 7. Seventh value here to seventh value here, right? But we have 3 more values down here that haven't been matched up, right? So in order for it to continue with the longest list, right, it needs to match 8 to 7, 9 to 7, and 10 to 7, right? And that's why you get 1, 2, 3 lines, right? With 8, 9, and 10 all matching up to number 7 here, right? So again, by default, longest list behavior, right? That's what we're seeing. Now, if I go to my sets tab and I go to my data matching tools and I choose, say, the shortest list, right? What do you imagine this will look like, right? If I connect a list that has 10 items and then a list that has 7 items, right? And I use that as a start point and an end point, you can see that because we're prioritizing this list that only has 7 items, we're completely ignoring the last 3 points on our longer list, right? And so you can see 0 to 0, 1 to 1, 2 to 2, 3 to 3, 4 to 4, 5 to 5, 6 to 6, 7 to 7, and then 8, 9, and 10 just get ignored, right? Finally, if we look at the cross-reference component, right? Where every value gets matched up to the other so that there's no values that aren't matched up. You can see the result is that you have a lot of data that gets generated, right? Because every point has to match to every point, right? And you start creating, these kind of intersections and crossovers, right? And no matter how you modify the number, right? There's never really any problems matching up that data, right? Okay, so that's a pretty simple way to look at data matching, but maybe you guys should all try that on your own for a little bit, and then we'll move on to the next kind of data topic. All right. Okay, so now that we've had a quick introduction to data matching, let's look a little bit closer at understanding list structure. And we'll be investigating the kind of flattened and graphed tree components a bit. These are the ones that, the kind of tree tools that we use a lot of. So to set this up, we're gonna set this one up in a similar way as we did for the other one. So we'll start, I guess, with something that's kind of working with data purely. So let me go ahead and set up our data, right? So here we'll work with sentences, right? So the cat is we'll use 3 in this list. my my dog is, and whose fox is. We'll add a second set of actions, so or descriptions actually. Quick, fat, jumping. Let's add one more so we don't have the same number. Looking at you. Okay, so 2 sets of data, right? And we're going to put them together into a text container. Again, paying attention to the order that we do so. Okay, and then let's set up a panel so we can see the result. Right, as expected. And we'll use something from our set. We'll use our weave component, kind of mix and match those datas together, right? So essentially what the weave component will do is it'll take 2 streams of data, right? And match them up in a specific pattern, right? And this is a pattern that you can define on your own, right? And so there's a lot of flexibility in that way. But by default, the pattern that it has is 0 and 1, right? And so this 0, 1, and 1, that describes streams 0 and 1. And like a lot of these tools or these components in Grasshopper that have, a, a set of inputs like this that have, values, right? Normally what that means is that if you zoom in on that component, then you can actually add additional streams, right? So you can see here, if I wanted to, I could continue to add inputs, right? Which means that my pattern, right, wouldn't necessarily just consist of 0 and 1s. I could have, any value of these, right? And so depending on how I set up that pattern, right, these things would get woven together, right, in a different way. In this example, we'll keep it a little bit more simple. We'll just use 2 streams, right? Because we only have we only created 2 sets of data. And we can accept the default of 0 and 1, right? As a, weaving pattern. Actually, I think let's do another one. So we'll have 3 sets here. So in each case, we have this being inputted as 0 and this being inputted as our 1 value. Okay, so from there, we can look directly and see what happens when they get woven together, right? And we'll do that using, again, our panel. So for the first one, you can see that the combination, right, of list 0 and 1 being woven together results in a list like this, where it says, okay, so 0, I'm going to take 0, right? Put that on. Then I'm going to take a value from 1, list 1, right? And then I'm going to put that on, right? List 0 again, list 1, list 0, and list 1, right? Note at the very end, right, we have 2 descriptors together, right? Jumping and looking at you, right? Jumping and looking at you. Both of which are from our list 1 here, right? Again, that's an example of longest list behavior being the default behavior, right? So that it preserves, right, that value there. And so if you wanted to, you can come into our sets, right, and choose the behavior that you wanted as well, and use that component to control, what goes into our weave component, right? We're not going to do more about that in this section because we want to focus this example on working with the list structure and the tree graphed and flattened components. Okay, so let's take a quick look and see what happens, right, if we take that same exact thing, right? So far, remember, all 3 of these are exactly the same. We haven't changed anything about those 3 components, right? They have the same pattern and everything. Inputs are the same, right? The only thing we're going to change is we're going to change the structure of the data that we're going to put into it, right? So right now, you can see that these are all single line data, right? A specific value, right? And when we put 3 values together into one component, right, it becomes a list, right? So now we have one list, right, with 3 values inside, right? And you can see that structure here in this panel, right? It has this darker bar here with this 0 inside, right? That's the address for that list, right? Same with below, right? 4 values combined together to create a single list with those 4 values in it, right? And so we input, in our first example, 2 lists, right, into our weave, right? And we're left with one list with 8 values, right? Now, what would happen then if we were to change the structure of one of those inputs here so that instead of being one list with 3 values, right, we had 3 lists with 1 value in each, right? So let me show you first what that looks like so that this will be clear. So we have the tree graphed and the tree flattened components, right, under our tree tab. And these two components are what allow us to modify the list structure, right? So right now we have this list, one list with 3 values inside. And if I were to use the graphed component, I could change the way that data is structured so that instead of being, again, one list with 3 items, each item is on a list of its own, right? So you can see that now it says this is on list 00, this is on list 01, and this is on list 02, right? The other thing to notice is that here, they're all zeros, right? Because this is item 1, right? The first item, number 0 on this list. This is also now going to be item 1 or item 0, first item in list 1. And as well as this one is item 0 on list 2, right? Whereas before, if you had one list, the only way to reference, right, these 3 items is if these 3 had different ID numbers, right? Okay. So if other thing to notice again is like we mentioned the dotted line, right? So here, when it was one value going into another, right, you had a solid line. When you had a list, right, you had a double line, right? So this is a list going into here. When you have multiple lists that are moving from one component to another component, that's when you get this dotted line, right? So in this case, we have 3 lists. So what is the result then if we were to replace, right, our second stream, right, with 3 lists with 1 item each instead of a single list with 3 items? You can see that the result that we're getting is dramatically different than what we did, than the result that we got just above it, right? So what's happening is that because the hierarchy of the data coming from here under stream 1 is different than the hierarchy of the structure in data stream 0, they can't be matched up under the same list, right? So what happens is that this set is being added to this list, right? And so every time a new list comes in, this list gets added to it. So you can see the cat is, right, quick, fat, jumping, looking at you. Quick, fat, jumping, looking at you. My dog is quick, fat, jumping, looking at you, right? So the way that that data got matched up is now completely different, right? So what do you imagine, right, that would look like if we were to do the same thing, but have both lists grafted, right, first. So if we were to take list 0 and list 1, right, and we look at them in their grafted form, we can see that now both lists, right, have the same hierarchy, right, because it's a list of lists, right? So, if we imagine the matching that will occur, we would think, okay, then since this happened because they were on different levels, right? There is a list and a list of lists. And so the list could only go inside the list here. But if they're both lists of lists, then the behavior of this weaving should be, right, that it would combine this one, list 00, right, the contents of list 00 with the contents of list 00 here, right? So we would get the cat is quick, right? And then it would say, okay, this is a different list, 01, right? But this is 012, right? So it should match and say, then my dog is fat, right? And then whose fox is jumping, right? Finally, again, because of longest list behavior, it'll get whose fox is looking at you. So whose fox is should appear twice, right? So let's confirm that. If I switch this with this and this with this, and I use the weave, right? Is it true that that's the result that I'll get? And there it is, right? So because the hierarchy of the data was the same, right? We can see that they were able to match, right, layer by layer, right? And so now we have 4 lists, right, each with a single statement, except at the end where, the fox is jumping and the fox is looking at you gets repeated, right? Similar to what happened up here in terms of the matching, except at the end, right, where it just repeated the longest list, right? So, okay, so then we're able to match it this way, but now we want that all to appear on a single list, right? Instead of in 4 separate lists. To do that, that's when we would use the flatten component, right? So essentially what the flatten component does is it reduces the hierarchy by 1 level, right? So we've eliminated the extra lists, and we've kind of put everything onto a single list, right? And so now it says the cat is quick, my dog is fat, whose fox is jumping, and whose fox is looking at you, right? So you can see having a strong understanding of how the data gets passed depending on the structure of the list is critical to having good control of your parametric definition, right? Because the difference between this list and this list is pretty subtle, right? You can see that they're almost the same except for one value, right? Where here it said jumping, looking at you, jumping, looking at you, instead of whose fox is jumping and then whose fox is looking at you, right? Because this created at the end a sentence, something that wasn't a sentence, right? Whereas this, in each case, created a proper sentence, basically. So, you know, if I were to tell you that this is the result that I want, right? And then I were to ask you, how can I get that from this set of data, right? You would have to be able to understand how these components work together to rearrange into the order that I was looking for, right? And again, that's a situation that you will run into all the time when you're creating definitions, right? Is that you want to be able to control what data is getting sent where and in what structure, basically, right? And so these tools, right, an understanding of how these tools work together to create the data structure that you're interested in is going to be very, very important. Okay, so let's do another quick example. And this time we'll look specifically at, I should have, actually, before we move on, so we've been looking at data this whole time using our panel, right? To kind of examine what's happening and to make it very clear, right? The difference between, this structure, or, this kind of structure, right? But we can also come into our parameters and go to utility and choose our param viewer, right? To see that difference. So if we connect something like this, you can see that it provides a description, data with one branch, right? Branch being a list, right? And N indicating the number of items or values inside that list, right? 0 to 6. If you double click it, it'll show you a kind of visual representation of what that looks like. If we did it to, let's say this one here, you can see that it tells us data with 3 branches, right? So 3 lists, 1, 2, 3, right? Essentially branches for the tree. And on each branch, how many values there are, right? There are 5 values here, 5 values here, and 5 values here, right? And 5. Double click, and you can see the structure of that data there, right? And then finally, look at this one. So data with 4 branches, right? 4 lists, and each list has 2 items in it, and that looks like this, right? 4 branches on your tree. And at the end, right, the values. So it doesn't really make sense to use these panels, right, for everything. The only reason I'm doing that is for clarity, to explain what's happening. But, in your own definitions, you probably, won't, have these all over the place, right? And if for some reason you needed to be able to see what was happening, you could just use the param viewer component, right, under utilities, right? And then, get a summary of what the kind of data is that you're moving from one component to the next. Right? The other thing that I should mention is that we've been looking at the flatten and the graft, right, as separate components. But in reality, these components are so important and used so frequently that actually people rarely use the components themselves, right? typically what people will do is they'll right click into whatever input they want to change, and then you can see you have the ability to modify, right, using a graphed, right, or a flatten, as well as things like a reverse, etc., right? So if what I was doing here wasn't a, explanation or tutorial, I probably would not use this. I would just skip it, right? Connect this directly, connect this directly to here, then just tell it to graft, right? And you can see it adds this little icon, right, to let us know that this is grafted, the data. And the result here is the same, right? Again, you could do, whatever you wanted basically, but just use the kind of right click inputs. So if you're comfortable, if you already feel pretty comfortable with it, you don't need to use these components at all, nor do you need to have, a panel for everything, right? This is just purely for the sake of clarity in this example. Okay, so let's look at another example then. So in this next example, I guess what we can do is we can use, let's just generate some data points and see what happens in terms of the differences that we see if we were to flatten the data or have the data grafted, right? So we're going to use one of our sequence components to generate generate values, not random values, right? And the one we're going to use is this one called sequence. So what sequence does is that it just generates a series of values, right, that start at something, have a certain step size, and a certain number, right? So you can see by default, the series generated a single list with 10 values, right? And those values are incrementing 1, 2, 3, 4, 5, 6, all the way till 9. And so you can see here, we expect the count to be 10, the step to be 1, and the start to be 0, basically, right? Now we can change any or all of those values, right, to something more interesting if we like. But it's a very useful tool for generating a series of numbers, right? So if I change those all to 10, for instance, you see that now item 0 is 10, number 1 is 20, number 2 is 30, right? Because the step size is 10, right? So incrementing by 10 times to 100. I can, of course, I can modify these, right? And if I were to create two sets, and then I were to say plot points, so curve vector, right? And I said, okay, I want to use this value for the X and this value for the Y, right? Go ahead and start from the 0, right? And by doing so, now I'm generating, right, with this set of data and this set of data. If this is X and this is Y, and then this is X and this is Y, right? We're plotting each of these points, right? So I get this kind of diagonal line, right? With 2 in the X, 3 in the Y, 2 in the X, 3 in the Y, 2 in X, 3 Y, right? And if I change that, right, that will react normally, right? But these two lists, they have the same structure, right? Two lists with the same values, number of values, right? So let's go ahead and say, okay, I want to graft one of those lists, right? And you can see immediately that now I'm generating a whole matrix, right? Out of this same combination. Why? Well, if we look at the data that gets generated once we graft, you can see that now we have 10 lists, right? Each with 10 values in them, right? Similar to what we saw here, right? We have 3 lists with 4 values in them, right? So if we were to use our param viewer here, we would expect what? Data with 10 branches, right? And then 0, 0, and 10, 0, 0, and 10, 0, 1, and 10, etc., right? So let's confirm with our param viewer, right? Data with 10 branches, number on each branch is 10, right? So we get 10 by 10, which is 100, right? Now, because these items, right, have a certain structure, right? We go back and we use, say, our list item under display. Sorry, a point list under display. And I say, okay, assign a point numerical value to each of those points on the list. Let's do 2 and see what happens first. 1, right? You can see that the pattern that emerges shows us how this matrix got generated, right? Because you have a pattern from 0 to 9, right? 0 to 9. Then the next list is 0 to 9. And the next list is 0 to 9. Next list is 0 to 9, right? Okay, but what if we didn't like the pattern that was emerging here, right? We didn't like it that it was applying in this way. Well, what could we do? Well, we could change the structure of this data, right? Let's say instead, why it's confusing for us to have, 0 to 9s. Instead, we would like it to be 0 to 100, right? So how could we change the way that these points appear on our matrix? It means that what we need is one list with 100 values on it instead of 10 lists with 10 values each, right? How can we do that? Well, isn't it pretty straightforward? All we would need to do is flatten, right, the data here, right? And I use the right click flatten. You could also, again, use our flatten component if you wanted to, right? And now, instead of having 10 lists, I only have one branch with 100 items on it, right? One list, 100 items, right? So now when I number it, it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then continues 10, 11, 12, etc., etc. So you can see that understanding, and we can reverse it to change the order, etc. So understanding how to modify lists and how to organize data can give us a lot more options in terms of what we have to work with, right? Okay, so I think that covers our discussion about list hierarchy, working with the tree components to flatten data or graft data, right? And then the effects of what that does to our, what the data that we're working with, right? And the options that we have. So play around with those components a bit and we will move on to the next topic. Okay, so now that you guys have had a chance to kind of play around with that, and you probably have all of this set up already, let's have a look at some of the most commonly used list modification components, right? So you can find all of these under set and list, right? And we're focusing on this set here up at the top. So I pulled out a number of components that are probably the most used. And in fact, we probably use some of these already, but let's just look at them quickly and see how they work. So where we left off, so we had grafted that list and then flattened it out here in order to get everything down to a single list of values, right? And so numerically, when we asked it to view the order in which they're generated, they now generate from 0 to 100, or rather 0 to 99, rather than 10 rows of 0 to 9, right? So we know that the list as it currently stands is one list with 100 values on it. But if we didn't, we could use, for instance, our list length component, right? And so it's a very simple component, and all it does is it takes any list that you put into it, right? And it spits out the value of the number of items on that list, right? So what you would get from that is the number 100, right? Because there are 100 items on that list. Now, usually that's we use this a lot because we're trying to do data matching stuff, right? And a lot of times if we're working with big data sets, we don't, maybe the number may be thousands and thousands, right? And instead of trying to go into, opening it up here or trying to view it or whatever, we just say, I don't care about, the specifics of any other part of it. All I want to know is how many values are there, right? So that, when I create my matching set of data, I can have the same length of values, right? And that's when you would use this list length component. Very straightforward. Now, list reverse, right? As you would expect, if you look here, we have on our Rhino preview that matrix from 0 to 99, right? And so all the list reverse does is change the order, right, in which those values appear from the last value, right, all the way back to the first value, right? So pretty easy to understand, I think. It's just reversing the order in which those points are appearing, right? Another commonly used one, and perhaps one of the, again, this is probably the most used, is this one called list item, right? And you can see by default, what I can do then is I can input that list that I have, right? This list essentially. And what this component lets me do is I can pull out specific values from that list that I'm interested in, right? So maybe, if I created a matrix of values from 1 to 100, right? But, I only want to keep values number 22 and 16 and 77 and 83, right? Those are the points I'm interested in. Then what I could do is I could have an index here of those values that I'm interested in, right? So I could either create a panel, right, and type in those values specifically, right? Or I could use a slider if there are not that many values. Say in this case 4. Yep. So if I were interested in number 22, right? Move this to 22. And it would find number 22 and put it on my new list of 4 items, right? So 22 is at 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 4 and 9, the coordinate. And then I could pick some other values from that list, right? There it is, right? So that's not the data that I'm interested in. And then you could go and do something like create a surface with 4 points, right? Although in this case, they want them as separate inputs. So again, because here it's separate, I would need to pull them all out separately, individually, in which case it doesn't really make sense to use the list item in this way. Let me see if I can find, I know, a curve, right? Right? So I want to draw a curve through those 4 points. So I'll just take those 4 points, put it there. Oops. This is divide. Why am I using divide? Primitive. Oh, spline. Here we go. Okay. There. And we take 22, 42, something else, and something else. Right? I don't know what those values were. 23, 61, 23, and then 86, right? If I modify, you can see, that it's basically plotting those 4 points, right? And creating the curve that I'm interested in, right? If I wanted to do a surface, right, that had 4 corner inputs, right, instead of a list, in fact, it would not be very useful in that case for me to generate a single list with 4 items on it. Instead, I might go for doing it separately. I mean, like this. That doesn't look great. Okay, let's not do it that way. So what I will do instead is do these all separately. So I can pull out specific points from my matrix and have each of those represented in this way. Right? So I'm pulling out number 23. I'm pulling out number 70. I'm calling out number 40, and I'm calling out number 38, right? And then using the output as my corner point to generate this surface, right? And then these are still, potentially modifiable, right? So that's essentially how you would use, this is simply a way of extracting a specific item, specific value or set of values from, a longer list, right? To use to do something else with, right? In case you didn't want to have the entire list as your data. Okay, next, let's say I wanted to change the structure of this list, and I wanted to break it down into parts, right? So what that does is I can input the list, and then I can choose sizes, right, of chunks, right, or partitions. So by default, the value is 3 and 2, right? If I wanted to change that, I could change it here by right-clicking into it, 3 and 2. Oops. Excuse me. Let's say 7. Okay. So when I do that, you can see that what will happen is that now I'm getting 0 and 1, 2, right? And then resetting to 0 and then 1, and then resetting to 0, 1, 2, 3, 4, 5, 6, right? And it's following this pattern of 3 items, 2 items, and 7 items, right? So what that looks like is this, right? It's changing the hierarchy of the data, right? And structuring, giving it more structure, right? So now instead of just one list with 100 items, I have many lists. How many lists? 25 lists. And those lists don't have all the same number in them, right? The number is controlled under your size input, right? And in this case, we've set it to do 3 values, 2 values, and 7 values, right? So it'll do 3, 2, and then 7, and then continue to repeat 3, 2, 7, 3, 2, 7, right? Therefore, when we chose to display the point list as numerical values, you can see here it goes 0, 1, 2, 0, 1, 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 0, 1, 0, 1, 2, 3, 4, 5, 6, etc., etc., and it continues on that way, right? So this allows us to organize our data manually into a new structure, basically. So this actually gives us a lot of freedom in that way. The split list, what it allows us to do is something fairly similar, but it just splits it into 2 parts, right? Into 2 lists, right? So instead of being one list, you have, um, an A list and a B list. So you can see if I say 55, then it'll create one list with 55 values, and then everything on list B will be the remainders, right? So 45 values left. And that just lets us define at what point, we want those values to split into 2 separate lists. And then finally, we have the insert item, right? So right now the list that we have is generated from something within this system, right? Now, if we want to add something to it from the outside, right? Let's say I create a point here somewhere, right? And then I just want to add that to this list. I can use here a point container, like this point, that one point, right? And now I would have my original list, the item that I wanted to add, and the location that I want it to appear at within my list, right? It doesn't change the physical location of that point, right? Because that's controlled in my 3D model, but it will change the order on the data list, right? So let's say I use a slider here for the indices, and I say 57, right? So now when I go to the point list and I input here, you can see it goes all the way up until 40, 50, 56, and then skips 57, right? Jumps to 57 out here, which is the point that we added, right? And then continues 58, 59, all the way to 100, right? So now there's 101 items on that list, right? So you can add items from outside of your original definition, right? Using the insert items under, again, all of these are found under the sets and lists. There are a few more of these, right? Like shifting lists and stuff like that. But I think the ones that I pulled out are just, the ones that you use more often. You can come in here and explore on your own to see, some of these sound interesting to you. Basically, shift just like, moves the order in one direction or another. But again, it really depends on what you're trying to accomplish with your list, the structure that you want, and knowing which are the right components, right? That'll help you get to your ultimate goal, right? So I think that's all we'll cover for the day. Next week we'll come back and we'll look at, for instance, these dispatch and pick and choose, right? A little bit more advanced kind of list modification tools, as well as, again, we'll probably explore, culling, even though we touched on that before. We'll look at the range component and how to work more with series to generate data. Yeah. So, okay. So I think we'll finish with that, and I will see you guys next week. All right.